Okay, so this is the last part of the series on logic gates. So far, I've taught you what logic gates are, the truth table, how to remember the inputs of the truth table, how all the different logic gates and how to derive the outputs of all the logic gates. Talk to you about what universal gates are, how to form equivalent circuits using universal gates. I've talked to you about the context that we are we need to know in order to bring logic gates and the highs and zeros into one to help us make different decisions based on different situations. Okay, and the last part that I need to tell you is where and how logic gates exist. So logic gates exist on something called IC chips. Yeah, so this is a picture of an IC chip. This is a picture of an IC chip. The one that we are going to work on is this one. Yeah, this is a dual inline DIL IC chip. IC stands for integrated circuits. Yeah, so all the components are on one chip. This is also an IC chip, but this is mainly for PCB boards when we solder on stuff permanently. When we work with breadboards, when we are still in the prototyping phase, we use these DIL IC chips. Okay, so we are going to kind of take a sneak peek into what is inside this black rectangle here. Now, these are all the IC numbers. When you go to Simlim Tower to buy IC chips, or if let's say you want a NOR gate, all you need to do is go to Simlim Tower, tell the uncle there, Uncle, I want to buy 74LS02. So the uncle will go to this tray and he'll pick out this 74LS02 IC chip for you. Different manufacturers will manufacture their version of 74LS02, but they're more or less the same. So just tell the model number of the IC chip and you're going to be pretty certain of getting a NOR gate. Okay, and so on and so forth. So do you need to remember the model numbers? Actually, not really. You do not need to remember them. But it helps. It helps so that whenever you look at the IC chips themselves, you're kind of getting a rough idea as to what um, type of ICs you are working with. Okay, so if you're wondering what are these BCD to 7 bit counter 555 voltage comparator, I haven't taught you yet, but they are IC chips that I'll be teaching you to work with. So these are quad means there are four chips. Sorry, quad means there are four gates inside a two input IC chip. Okay, quad means four. Triple means there are three gates inside a three input AND gate. So there are different types of AND gates, different types of inputs, depending on what you need. Yeah, so I really can't tell you so which one is the best, which one works, which one doesn't. It really depends on the situation that you're facing, and from there we choose the type of IC chip that we want. Now, the next part that you have to pay attention is identifying the pin numbers. So every IC chip will either have a notch here or a dot here. It's very obvious. Yeah, I think some of you have seen it already. So either a notch or a dot here. And always the pin to the left of the notch or a dot is number 1, first pin. And then 1 to 7, 8 to 14. So you have to remember the numbering convention. Okay, so remember the numbering convention. And how do we know what each of these legs do? Like, so what if I know the number, what do they do? Whenever you're not sure of what a component does, always refer to the data sheet. So let's look at the data sheet of a 74LS08. So this is a quad 2 input AND gate. Remember, quad means there are 4 gates, and each gate has 2 inputs. So this is what it looks like inside internally. Yeah, how they build the AND gate, you don't have to know that. All you need to know is that pin 1 and pin 2 are the inputs to the first AND gate, and pin 3 will give me the output. So 1A, 1B, 1 representing the first gate, A, B representing the two inputs. 1 representing the first gate, Y representing the output. Okay, so if you just need to use one gate, you just need to use pin 1, 2, 3. That's all. If you want to use two gates, you have to consider which other two gates you want to use. But if you want to use the second AND gate, use pin 4, 5, 6. So pin 8, 9, 10 is for the third AND gate, and pin 11, 12, 13 is for the fourth AND gate. Yeah. So this chip kind of needs power. To power on this chip, you need to have a VCC pin. This is pin 14, and you need to have a ground pin, pin 7. Okay. The datasheet will also give you the truth table. A low is equivalent to a 0, and like this. And yes, this is the truth table of a AND gate. Datasheet don't lie. Now, so certain things that you have to take note of in the datasheet. The supply voltage, please do not exceed 7 volts. Yeah, temperature do not exceed 70 degrees Celsius. I don't see how it can reach 70 degrees Celsius, but don't. So for a normal supply voltage, stick to 5 volts. This is not an issue. 9 out of 10 times we work with 5 volts in our course. That's not a problem. This tells me that the input voltage, in order for it to consider it a high. Now, I know a lot of you think that, I know a high is a 5 volts and a low is a 0 volts. In an ideal fairy tale world where the prince wakes up the princess world. But in real life, we seldom get a very nice 5, a very nice low. So there are variations, yeah. So this number tells me that this chip will recognize it as a high if you input in anything above 2 volts. And this chip will represent it as a low if you input anything below 0.8 volts. Okay, so if I can draw a number line from 5 volts to 0 volts, anything below 0.8 volts, they'll consider it a low, and anything above 2 volts, they'll consider it a high. And some of you will be wondering, okay, that's all nice, but what if my input lands in between? That's where I can't answer you, because it's going to be uncertain. The output is going to be uncertain, and that's not what we want. So the moral of the story is, make sure your inputs are a definite high or a definite low. Then you'll know that your IC chip will give you the correct output. Okay, and this one, well, in case you are interested in knowing, the output, right? So this is the N. The output here, uh, the minimum output it'll give for a high is actually 2.4 volts. Yeah. And the maximum output for a low it'll give is a 0.4. So even the output is not going to give you a nice 5 volts or a nice 0.0 volts, even the output. So when we are doing the practicals, don't come to me and say, oh, there's something wrong. My output doesn't give me a 5 volts, even though it's a high, and then the output, why is it only giving me a 3 volts? It's how it's made. Okay, so typically they will give you a 3.4 volts. Here, typically a low will give you a 0.2 volts. Yeah, so it won't give you a nice 5 volts, it won't give you a nice low, a 0 volts. If you want a nice high, a nice low, use a pull up or pull down resistor to help you achieve that. Okay, and that is more or less it for data sheets. Yeah, so just to summarize, make sure that you know IC chip is where all your gates are residing in. Know how to recognize the notch, and the first pin directly to the left of the notch is your number 1 pin, all the way down to 14 pins. Now, there are some IC chips with 8 legs, but the way to recognize pin 1 is the same. Look for the notch or look for the dot. The pin next to it will be the number 1 pin, and you count from there. Again, if you're not sure, don't ask me, don't ask the friend beside you, look for the data sheet. It will give you a very clear and concise diagram to show you the pin numbers and the truth tables. Okay, so that is it for the chapter on logic gates, chapter 11. I hope this lecture series it gets you a little bit of clarity in understanding the chapter. If you're not sure about anything, you can always go back to watch the videos, and failing that, if you still don't know, understand, if you still don't understand anything, you can come look for me or email me. All right. So with that, I wish you the best of luck, and I'll see you for the next video series. Ciao.